So how to do scientific research, and let's start with what makes research scientific. This is written by a combination of multiple articles. Systematic approach, following organized, repeatable steps so other labs and people can repeat your research. Objectivity, remaining neutral and unbiased. Don't manipulate your research so you get a certain result. Just do the research and see what you get. Evidence-based, relying on observable, measurable data. Peer review, open to scrutiny and validation by other scientists. Ethical standards, adhering to moral and professional guidelines. There are different types of scientific research, so by data collection method there are observational, studying phenomena without intervention or interaction. Experimental, manipulating variables to test cause and effect. In AI, usually we do this. By purpose, descriptive, documenting what exists. This could be a survey on large language models, diffusion models, and analytical, understanding why and how things occur, training a model and understanding it. By time frame, prospective, following subjects forward in time, retrospective, looking back at the past, cross-sectional, examining a specific moment in time. Step 1. Ask a question and define your research problem. Every scientific investigation begins with curiosity. It doesn't begin with you wanting to get a job at OpenAI. It begins with curiosity. Scientists make observations about the world and identify gaps in current knowledge. Your research question should be specific, clearly defined and focused. This is what a lot of people struggle with currently in AI. There is just too many things to research. I mean beginners. But once you achieve some kind of mastery in this AI field, you will know exactly what to research. Measurable, capable of being tested with available methods. Relevant, addressing a genuine gap in knowledge. Feasible, achievable with your resource and time frame. So this is also important in AI. People put maybe a bit too difficult goals for themselves. Question frameworks. Use these question words to guide your inquiry. How does X affect Y? What causes this phenomenon? When does this occur? Why does this happen under certain conditions? Which factors are most influential? Where does this pattern appear? Now, AI research in particular. There are a few different types. By focus area, they are divided in core AI ML, new algorithms, architectures, or theoretical foundations. And then application in healthcare, robotics, NLP vision. Infrastructure deployment, scalability, and safety, alignment, fairness, societal impact. Step 1. Ask a question and define your research problem. Identifying research opportunities in AI. AI research questions often emerge from performance gaps, current methods failing on specific tasks, efficiency challenges, high computational costs or memory requirements, understanding why models work, adapting AI to new domains, bias, fairness and safety issues, moving from toy problems to real-world scale. Your research question should be novel, addressing unexplored areas or new perspectives, impactful, potential to advance the field or solve important problems, feasible, achievable with available computational resources, measurable, clear metrics for success. Here are some examples. How can we reduce the computational complexity of transformer models while maintaining performance? What architectural changes improve few-shot learning in vision models? Why do large language models exhibit emergent behaviors at certain scales? This one is very interesting. So this is also asking how to scale things. If we do some experiment on a bit of compute, how is it going to scale on a lot of compute? This might be one of the most important experiments. You can read other ones if you want. So this is example of question or problem development improvement. So initial observation. Large language models require enormous computational resources. A refined problem. Training costs limit accessibility of state-of-the-art models. Research question. Can we develop a knowledge distillation method that preserves 95% of GPT-3-4 performance while reducing model size by 10x? You probably can. And then we go to even more specific research question. For example, how does progressive knowledge distillation with task-specific fine-tuning affect the performance efficiency trade-off in large language models across different NLP benchmarks? Then it's important to maintain a research notebook to document your research, digital or physical, experimental configurations and hyperparameters, daily progress and observations, failed attempts, this is important, and lessons learned. Fail result is as good as a successful result. It just doesn't get so many views but on YouTube or LinkedIn, but it's as valuable. So other labs don't need to repeat the same experiment just to find out it doesn't work. Ideas for future experiments, this is interesting. Meeting notes and feedback, maybe from your mentors or peer review. Code version control commits. Step 2. Conduct background research and literature review. Understanding the AI research landscape. So it says here these journals, but you're not gonna search this by hand anymore. Now you can use deep research like Perplexity or whatever. People had to search this by hand before. So there are many tools to do this research. You can prioritize more reputable institutions and researchers. When reading a paper, you can go abstract and conclusion and then scan figures and tables, or you can just put it into AI like this and tell it to explain. It's way better, I think. You can organize your literature in some files and folders. And then identify research gaps. And also there is section future research on a lot of papers, so you can find your next research there. Then you can start to formulate your hypothesis. For example, if we modify architecture or algorithm by specific change, then performance metric will improve because theoretical or empirical reasoning. Make sure to set up your experiments properly, like fix random seeds and make it fair. This is example of your project. Configs, data, models, training, evaluation, experiments, results, notebooks. You can check my videos and maybe get some inspiration for your research. Also this video, publish your own LLM, which is somewhere, I don't know where. You can copy paste my LLM, it's very simple, small, you can run it on Google Colab and do experiments. You can use AI IDE like Cursor or Windsurf or Kiro or something. You can use AI to code image plotting to analyze images. I think AI coding and analyzing images is so helpful in AI research right now. But the biggest problem with me also is finding out what I want to research. There is too many things, but we'll figure it out eventually. In a year, we'll probably figure it out. So shortly, define a question to investigate, make predictions, gather data, analyze data, draw conclusions. If you just search Google to how to do scientific research, all of these are so nice. That will be it for this video, and see you next time.